Hi, and welcome back to AWS Julie. Today we're continuing a new playlist where we talk about the machine learning fundamentals that you need to understand to help you prepare for the AWS Certified Machine Learning Engineer Associate Certification Exam. And we are starting Domain 4, which is Machine Learning Solution Monitoring, Maintenance, and Security. So throughout this course, we have been talking about the first 5 steps of the machine learning engineer lifecycle and the well-architected machine learning lifecycle. And this domain 4, covers the 6th step of both lifecycles, which is to make inference and also model monitoring. So let's get started with our first task statement from domain 4, which is to monitor our model inference. And let's step back to fundamentals and talk about the 6 steps of both the machine learning engineer and the well-architected machine learning life cycles, which is to make inference and model monitoring. And let's pause and define both. So machine learning inference is the process of running data points into a machine learning model to calculate an output, such as a single numerical score. Model monitoring ensures your model is maintaining a desired level of performance through the early detection and mitigation. And in AWS, your model monitoring system must capture data, compare that data to the training set, define rules to detect issues, and also send alerts. So this process repeats on a defined schedule, and when it's initiated by an event or when initiated manually. The issues detected in the monitoring phase include data quality, model quality, bias drift, and feature attribution drift. In the last few lessons, we talked about how after our model is trained, you then host the model somewhere to compute the answers to your questions. So for this task statement 4.1, we're talking about the 6 steps, which are to make inference, and this is completed using the model with new data and monitoring that model. There is often a need to retrain a model using new or updated data to ensure that the model is able to effectively learn and predict based on the most current data available. To be able to effectively incorporate additional data into a machine learning model, there must be a mechanism implemented to analyze existing model performance against defined metrics and initiate an alarm or a retraining event when the model variance reaches a specific threshold, or proactively retrain the model over time based on new known data. For a model to predict accurately, the data that is making predictions on must have a similar distribution as the data on which the model was trained. And because data distributions can be expected to drift over time, deploying a model is not a one-time exercise, but it's a continuous process. It is good practice to continuously monitor the incoming data and retrain your model on newer data if you find that that data distribution has deviated significantly from the original training data distribution. If monitoring data to detect a change in the data distribution has a high overhead, then a simpler strategy is to train the model periodically. So for example, you would train daily, weekly, or monthly. In order to retrain your models in Amazon SageMaker, you need to create a new model based on your new training data. To track your model over time through metrics such as your model accuracy and drift, you can use Amazon SageMaker Model Monitor. With Model Monitor, you can set alerts that notify you when there are deviations in your model's quality. So for example, you can monitor your endpoints health through the metrics such as invocation errors and model latency using CloudWatch metrics. And the SageMaker endpoint invocation metrics can provide you with valuable information about your endpoint's performance. Model Monitor monitors the quality of your SageMaker models, and you can set up continuous monitoring with real-time endpoint or a batch transfer job that runs regularly or on a schedule monitoring for asynchronous batch transform jobs. With Model Monitor, you can set alerts that notify you when there are deviations in the model quality and take corrective actions, such as retraining models, auditing your upstream systems, or fixing quality issues without having to monitor models manually or build additional tooling. You can use Model Monitor pre-built monitoring capabilities that do not require coding or bring your own code to provide a custom analysis. So for the exam, ensure you understand how to monitor the data and the model predictions, run analysis of model performance against defined metrics to identify errors due to data and concept drift, automate model retraining to mitigate these errors on fixed scheduled intervals, or when the model variance reaches a defined threshold, or when new data becomes available. To establish an automated retraining framework, you can monitor data statistics and machine learning inferences using Model Monitor. If the data drifts beyond a defined threshold, then you can start retraining at defined scheduled intervals or when additional training data is available. So for example, you can configure automated retraining based on new data put to an Amazon S3 bucket. And it is best practice to ensure model versioning is supported when incorporating additional data into your models. You can also develop a retraining pipeline using Amazon SageMaker pipelines for orchestration using step creation and management. And you can use SageMaker projects to orchestrate and manage building custom images for processing, training, and inference, data preparation and feature engineering, training your models, evaluating models, deploying models, and monitoring and updating models, which is the focus of this task statement. You can also use AWS Step Functions Data Science SDK for Amazon SageMaker to automate the training of a machine learning model. So how does that work? Well, you define the steps in the workflow and set up alerts to start that flow. Then to detect the new training data in an S3 bucket, you can use AWS CloudTrail or Amazon CloudWatch events to start an AWS step function workflow to initiate retraining tasks in your pipeline. So let's continue on with task statement 4.1, which is to monitor our model inference. And for your exam, ensure you understand the effects of data drift on model performance and implement strategies that monitor and adapt to data drift through retraining. You can use SageMaker Model Monitor and SageMaker Clarify to maintain high-quality machine learning models and to detect model and concept drift in real time. Model Monitor is integrated with SageMaker Clarify to help you identify potential bias in your machine learning models. With this solution, you can configure alerts, receive notifications, and take immediate action. The way it works is the model and concept drift are detected by monitoring the quality of the model. Also, ensure you understand how to monitor your model quality. Model performance can degrade over time for reasons such as data quality, model bias, and model explainability. And it is important to continuously monitor the quality of our machine learning models in real time. You also want to identify the right time and frequency to retrain and update the model. You need to configure alerts to notify and initiate actions if any drift in the model performance is observed. And again, you can monitor model performance with Model Monitor and establish a baseline during the training and before the model is in production. Then you collect data while in production and compare changes in your model inferences. Observations of drifts in the data statistics will indicate that the model may need to be retrained, and the timing of drifts will establish a schedule for that retraining. You can use SageMaker Clarify to identify model bias, and you can configure alerting systems with CloudWatch to send notifications for unexpected bias or changes in your data quality. Then you can monitor the model performance in production using A/B testing. And performing A/B testing between a new model and an old model with production traffic can be an effective final step in your validation process for a new model. In A/B testing, you test different variants of your models and compare how each variant performs. If the newer version of the model delivers better performance than the previous existing version, you can replace the old version of that model with the new version in production. Also, ensure you understand how to configure automatic scaling for your monitored metrics. Remember, Amazon SageMaker includes automatic scaling capabilities for your hosted model to dynamically adjust underlying compute supporting an endpoint based on your demand. If you want to monitor endpoint metrics, Amazon SageMaker also outputs endpoint metrics for monitoring the usage and health of your endpoint. Amazon SageMaker Model Monitor provides the capability to monitor your models in production and provide alerts when data quality issues appear. You can create mechanisms to aggregate and analyze model prediction endpoint metrics using services such as Amazon OpenSearch Service, which supports Kibana for dashboards and visualizations. The traceability of hosting metrics back to version inputs helps to analyze changes that could be impacting current operational performance. And remember to include human-in-the-loop monitoring to your model performance efficiently. When automating your decision processes, the human labeling of model results is a reliable quality test for model inferences. You can compare human labels with model inferences to estimate model performance degradation, and you can perform mitigation as model retraining. So how would that work? Well, you can use Amazon Augmented AI to get human reviews. And to design a quality assurance system for your model inferences, establish a team of subject matter experts to audit model inferences in production, and use Amazon Augmented AI to get human review of low confidence predictions or random prediction samples. Amazon Augmented AI uses resources in IAM, SageMaker, and S3 to create and run your human review workflows. Also, ensure you understand how to ensure your workflows detect anomalies or errors in your data processing or model inference. You can use AWS Glue data quality anomaly detection to apply machine learning algorithms on data statistics over time to detect abnormal patterns and hidden data quality issues that are hard to detect through rules. Also, Monitor Model has model quality monitoring jobs that monitor the performance of a model by comparing the predictions that the model makes with the actual ground truth label that the model attempts to predict. To do this, model quality monitoring merges data that is captured from real-time or batch inference with actual labels that you store in an S3 bucket and then compares the predictions with the actual labels. And ensure you understand how to deploy a machine learning model in Amazon SageMaker that provides product recommendations to improve the accuracy of the model and ensure it is providing high-value predictions. If you detect a significant change in customer data, then you can retrain your model using both the original and the new data. Machine learning workloads can initially provide high-value predictions, but the accuracy of the same model's prediction can degrade over time. And we talked about how this is due to drift, which can be a result of many factors that include changes to your ground truth data over time. As model predictions are integrated into business decisions, this can indirectly affect the performance of existing models. And you can retrain a model using new or updated data to ensure that the model is able to effectively learn and predict based on the most current data available. It is best practice to continuously monitor the incoming data and retrain your model on newer data if you find that the data distribution has deviated significantly from the original training data distribution. Let's dive a bit deeper here and ask a question. Can you retrain the model periodically using the original data and apply regularization to improve your prediction accuracy? Well, regularization does reduce overfitting, but retraining the model with the original data is unlikely to produce better results. Here's another question. Can you tune the hyperparameters to reduce model drift? Well, this solution also would be working with that original data. Instead, you need to retrain the model based on the original data plus the new data to give product recommendations. Let's move on and talk about the second task statement from Domain 4, which is to monitor and optimize infrastructure and cost. Before we begin, let's talk about implementing a resilient framework and using best practices. So what is a resiliency framework? Well, it is detecting the causes of failures and diving deeper into your dependencies. Do you have any operation dependencies, system dependencies, or libraries or regional dependencies? And remember to include any build time dependencies too, especially to autoscale or fail over. A resilience framework is also establishing a continuous monitoring strategy that includes your data strategy by using the correct and needed metrics, logs, and traces. You must know what requirements for resiliency are needed and which metrics to track, and also know how to refine and test to ensure continuous improvement. Make sure you dive deeper into the AWS well-architected framework and the 6 pillars. It is a great source to help you understand best practices for designing and operating reliable, secure, efficient, and cost-effective systems in AWS, while consistently measuring the architecture against best practices and identifying areas to improve. It is crucial to have the monitoring in place and the metrics identified to ensure operational excellence. Let's stay on fundamentals and ask a question. What is the difference between monitoring and observability? Monitoring is based on gathering metrics, logs, and traces. Observability adds the ability to monitor systems as a whole, providing full visibility. Understanding multi-layered architectures and distributed systems requires more than traditional logs and infrastructure metrics. Monitoring is an important part of maintaining that reliability, availability, and performance of the machine learning lifecycle. AWS also provides monitoring services and tools that you can use to monitor, report, and take action automatically when appropriate to remediate. But you also have to ensure observability. For the exam, ensure you know how to implement the needed collection and monitoring of metrics, logs, and traces for observability and transparency into your infrastructure, to your system events, actions, API calls, and more. AWS provides CloudWatch, AWS X-Ray, CloudWatch Logs Insights, GuardDuty, Amazon Inspector, AWS Security Hub, and more to provide monitoring and observability. To make your application observable, it must be instrumented to share traces, metrics, and logs to understand the raw data collected, to gain the insights from it, and add more visibility. So what AWS services are available to help you troubleshoot latency and performance issues in AWS? We've mentioned these services before, but let's start with Amazon CloudWatch. You can use CloudWatch to log and monitor Amazon SageMaker. For example, CloudWatch can be used to monitor SageMaker endpoints and detect anomalies in their performance, which can help optimize resource usage and reduce your costs. CloudWatch provides several metrics related to SageMaker endpoints, such as endpoint latency, endpoint invocations, CPU and memory utilization, and data input and output rates. These metrics can be visualized using CloudWatch dashboards, which allow our users to create custom metrics, alarms, and notifications. SageMaker automatically sends metrics to CloudWatch so you can gather and analyze your usage statistics for your machine learning models. Here's another example. To keep track of batch and real-time predictions, you can monitor the predict count metric according to the request mode dimension, and you can monitor these metrics by using Amazon CloudWatch Console, the AWS CLI, or AWS SDKs. Amazon CloudWatch Logs helps to monitor, store, and access your log files from EC2 instances, CloudTrail, and other sources. You can collect and track metrics, create custom dashboards, and set alarms that notify you or take actions when a specified metric reaches a threshold that you specify. CloudWatch logs can monitor information in the log files and notify you when certain thresholds are met. Amazon CloudWatch Events delivers a real-time stream of system events and gives you the ability to write rules that watch for certain events and initiate automated actions in other AWS services when these events occur. For example, you can create CloudWatch events, rules that react to a status change in a SageMaker training, hyperparameter training, or batch transfer job. Amazon Event Bridge monitors the status changes in Amazon SageMaker. And using Event Bridge, you can automate SageMaker and respond automatically to events such as training job status change or endpoint status change. Events from SageMaker are delivered to Event Bridge in near real time, and you can write rules for events and what automated actions to take when an event matches a rule. CloudWatch also provides several features to help analyze logs and metrics, such as CloudWatch Application Insights, to collectively define and monitor metrics and logs for an application across different AWS resources, Cloud Anomaly Detection, to surface anomalies for your metrics, and CloudWatch Log Insights to interactively search and analyze your log data in CloudWatch logs. You can also use CloudWatch Service Lens to correlate traces, metrics, logs, and alarms for diagnosing issues. You should also consider including additional dimensions in metrics and identifiers in logs for your workloads to help you quickly search for and identify issues across systems and services. Amazon SageMaker also integrates with AWS CloudTrail, which is a service that provides a record of actions taken by a user, role, or an AWS service in SageMaker. CloudTrail captures all API calls for SageMaker as events except for invoke endpoint and invoke endpoint async. The calls captured include calls from SageMaker console and code calls to the SageMaker API operations. If you create a trail in AWS CloudTrail, you can enable continuous delivery of CloudTrail events to an S3 bucket, including events for SageMaker. If you don't configure a trail, you can still view the most recent events in the CloudTrail console in your event history. Using the information collected by CloudTrail, you can determine the request that was made to SageMaker, the IP address from which the request was made, who made the request, when it was made, and also additional details. And you can also store those logs in CloudWatch logs as well. CloudTrail only logs events for the AWS region that the trail was created in. So back to fundamentals, what type of service do you think that makes CloudTrail? CloudTrail is a regional service, but remember you can choose to allow CloudTrail to log for all regions in your AWS account, which makes it a global service by choosing all regions for your CloudTrail logs when you're configuring that trail. AWS Lambda automatically logs each invocation of your Lambda functions. You can also add custom log statements to your Lambda function using programming languages. And I want to talk about CloudWatch Lambda Insights, which is a monitoring and troubleshooting solution for serverless applications running on AWS. Lambda, running on AWS Lambda that collects, aggregates, and summarizes system-level metrics such as CPU, time, memory, disk, and network usage. It also collects, it aggregates, and summarizes diagnostic information such as cold starts and Lambda worker shutdowns to help you isolate issues with your Lambda functions and resolve them quickly. And to ensure auditing and traceability in AWS, you can deploy logging and monitoring solutions that capture and analyze activities and events across your infrastructure and services. What AWS services are available to ensure traceability? Well, AWS X-Ray can provide end-to-end tracing and analysis. If you have a large-scale application with distributed architectures and microservices, X-Ray can help to visualize and understand the interactions between components of your application and can be valuable for performance optimization and resource and issue resolution. And to ensure the accuracy and the reliability of the data for traceability and audits, it's important to verify and clean that data. AWS also provides services for data verification and cleaning, such as AWS Lambda, Athena, QuickSight, Jupyter Notebooks, and Amazon SageMaker Data Wrangler. Let's continue on with task statement 4.2, which is to monitor and optimize our infrastructure and costs. And picking up from our last lesson, you have captured your metrics and logs in a consistent format and location to search and analyze those logs. Most workloads use AWS resources such as network compute, storage, and databases, and it is important to collectively analyze the metrics and logs from these resources and correlate them in order to effectively monitor and manage all of your AWS workloads. Tracking metrics and logs and events helps in the process of auditing your applications, systems, and infrastructure in AWS to troubleshoot and identify root cause, and implementing real-time logs to CloudWatch using subscription filters can deliver logs to a Kinesis stream or Kinesis data Firehose stream or Lambda for processing and analysis. Let's continue on with task 4.2. And to ensure cost optimization with real-time endpoint monitoring, you can use SageMaker tools and techniques. CloudWatch Metrics and Alerts, SageMaker Model Monitor, and Cost Explorer. In my AWS training content and the exam prep courses that I create for AWS Skill Builder, I talk a lot about cost optimization. Make sure you dive deeper into the AWS well-architected framework cost optimization pillar. Let's move on and talk about right-sizing our instances for cost optimization and performance. Right-sizing your instance is the first step in cost optimization best practices. For machine learning, it would be right-sizing your EC2 instances, but it also includes right-sizing your database instances. You can monitor SageMaker notebooks through CloudWatch custom metrics to optimize resource allocation and performance. SageMaker notebooks can be appropriately sized to minimize overutilized notebooks, which causes errors or wasted spend. By right-sizing and choosing the correct instance type, but also the cheapest instance type that meets your performance requirements, can save money. And by choosing the right instance and auto-scaling configuration, this can help reduce model serving costs without any disruption to your end users. So for the exam, ensure you understand how to choose the right instance family for your model, such as memory optimized, compute optimized, inference optimized, and more. Here are a few questions that you should ask. Do you need a solution that is more compute optimized for some type of batch processing? Or perhaps you need a memory optimized instance for processing large data sets in memory. The second cost optimization pillar is to increase elasticity and to only use resources when those resources are needed and not using resources when they are not needed. And that gives you a pay for what you use model. An example of this is horizontal scaling and using more smaller instances instead of a few larger instances for your model to reduce your cost. You can use auto-scaling to scale your instances up and down as needed to save money. And with auto-scaling, you can schedule instances for periods of demand. For example, for your production instances, you will need to be up and running 24/7. But what about your test environment or development environment? AWS provides confirmation templates, and they can be managed by tags. Tags are so important for cost tracking and allocation techniques. And you can use the Cost Optimization Hub to identify, filter, and aggregate AWS cost optimization recommendations across your AWS accounts and regions. It makes recommendations on resource right-sizing, idle resource deletion, saving plans, and reserved instances. And we mentioned earlier under the first cost optimization step that right-sizing your instances can be combined with an elastic load balancer to horizontally scale to meet your demand. Ensure you understand the different characteristics of the elastic load balancers and when you might choose an application load balancer, network load balancer, and gateway load balancer for your use cases requirements, and remember cost optimization too. After attaching a load balancer to your auto-scaling group, you can configure your auto-scaling group to use elastic load balancing metrics And you can add health checks to your auto-scaling groups so that EC2 auto-scaling can identify and replace unhealthy instances based on these additional health checks. And you can also create CloudWatch alarms that notify you if the healthy host count of the target group is lower than allowed. Here's a question. How do you troubleshoot latency with your Amazon SageMaker endpoint? Well, multiple factors might contribute to overhead latency, such as your payload size for requests and responses, the request frequency, and the authentication or authorization of the request. For a single endpoint, you can use CloudWatch to monitor the latency metrics, model latency, and overhead latency for a SageMaker endpoint. If you use a SageMaker multi-model endpoint, you could also use CloudWatch and track model load wait time, model downloading time, model loading time, and model cache hit. And then to reduce the latency, ensure you benchmark the model outside of a SageMaker endpoint to test performance. If SageMaker Neo supports your model, then you can compile the model, and SageMaker Neo will optimize the model to run up to twice as fast with less than a tenth of the memory footprint with no loss in accuracy. And AWS Inferentium supports your model. You can compile the model for Inferentium, which can add up to 3 times higher throughput and up to 45% lower cost per inference compared to other AWS GPU-based instances. If you use a CPU instance and the model supports GPU acceleration, then you can use a GPU instance to add GPU acceleration to an instance. For further troubleshooting, remember that the inference code might affect the model latency depending on how the code handles that inference, and any delays in code increase the latency. Also, infrequent requests might also lead to an increase in overhead latency, and an overused endpoint might cause higher model latency. To dynamically increase and decrease the number of instances that are available for your endpoint, you can add auto-scaling to the endpoint. Also, the first invocation for an endpoint might have an increased latency because of a cold start, but you can pre-warm the endpoint and send test requests. The third pillar for cost optimization is choosing the right model or choosing the right pricing model. Ensure you understand the different pricing options such as on-demand, saving plans, reserved instances, spot instances, dedicated hosts, dedicated instances, scheduled instances, capacity reservations, and so on. The SageMaker Savings Plan offers a pricing model that provides up to 72% savings on your AWS compute workload. SageMaker Saving Plans provide you with lower prices for your instance usage, regardless of the instance family, size, component, or region, and you can manage your plans by using recommendations, performance reporting, and budget alerts in Cost Explorer. The fourth pillar of cost optimization is to match your storage to your usage. And we talked about this earlier, but for compute optimization specifically, again, right-size your storage for your compute environment. Know the different use cases of why and what storage to use to match your workloads. The fifth pillar of cost optimization is continual improvement with measuring and monitoring to optimize your architecture. Your architecture will most likely continue to change, so you need to have measures in place to monitor and measure your usage and your cost. Monitor your utilization of CPU, RAM, storage, and so on to identify instances that could be downsized or may need to be increased and vertical scaled. And remember, you can use CloudWatch to track your metrics and set alarms to immediately take actions. You can also use other services such as AWS Cost Explorer, AWS Trusted Advisor, AWS Budgets, and more to define your metrics, set target goals, define and enforce your tagging strategy, use cost allocation tags, and make sure you regularly review for any infrastructure changes. Let's wrap up this task statement and talk about implementing and monitoring cost management solutions to understand your resource needs, how costs are allocated and to measure and monitor your infrastructure. But to define your metrics, set your target goals, define and enforce your tagging strategies, use your cost allocation tags, and make sure you're regularly reviewing for any changes. This requires a good understanding of cost management tools. For example, how do you use cost allocation tags? One way is to use tags to filter views in Cost Explorer to help you analyze costs. Also, know the capabilities of AWS cost management tools. For example, if you want a high-level interactive financial report, would you use AWS Cost Explorer or the AWS Cost and Usage Report? Cost Explorer gives you a high-level view that you can then drill down into more specifics. AWS Cost and Usage Report breaks down costs by the hour, day, month, product, resource tags, and so on. And we've mentioned alarms and alerting with CloudWatch, but you can also set up alarms and alerts and automate notification when your build exceeds a certain threshold. You can create billing alarms, free tier alarms, and alarms with AWS budgets. Ensure you understand how to optimize cost and set cost quotas by using the appropriate cost management tools. Dive deeper into Cost Explorer, AWS Cost Management, AWS Organizations, and AWS Control Tower to help you centrally manage billing, control access, compliance, security, and share your resources too. We mentioned right-sizing your storage earlier. Trusted Advisor can give you recommendations when it finds underutilized EBS volumes in your account. So having the monitoring in place establishes a baseline of your usage, and it's a big part of being able to right-size those volumes. Ensure you continue to track the correct metrics to determine if you need to modify your solution for cost optimization. You can also optimize the cost for EBS by paying attention to how many IOPS you are using and then comparing that to how many IOPS you're paying for. If you're paying for the most optimized, most performant volume type, but not using that capacity, then you may be able to change your volume type and save money without taking a performance hit. There's also data and storage lifecycle rules that we did not mention that you can use to automatically delete data that is no longer needed, and services such as Amazon Data Lifecycle Manager and AWS Backup that help you to automatically delete old Amazon EBS snapshots or backups from other AWS services, and this too can help you reduce the storage costs within your AWS account. There are also different options for optimizing the data migration costs for hybrid environments like AWS Data Sync, the Snow family, AWS Transfer family, and AWS Storage Gateway. Architecting for data transfer ensures that you minimize data transfer costs, and this may involve using content delivery networks such as Amazon CloudFront to cache data closer to the users, SageMaker Neo, or using dedicated network links from your on-premises to your AWS with AWS Direct Connect. Amazon SageMaker Inference Recommender is a capability of Amazon SageMaker that reduces the time required to get machine learning models in production by automating load testing and model tuning across SageMaker machine learning instances. You can use Inference Recommender to deploy your model to a real-time or serverless inference endpoint that delivers the best performance at the lowest cost. Inference Recommender helps you select the best instance type and configurations such as instance count, container parameters, and model optimizations or serverless configurations such as max concurrency and memory size for your machine learning models and workloads. AWS Compute Optimizer is a service that analyzes the configuration and utilization metrics of your resources. It reports whether your resources are optimal and generates optimization recommendations to reduce the cost and improve the performance of your workloads. Compute Optimizer also provides graphs showing you recent utilization metric history data, as well as projected utilization for recommendations, which you can use to evaluate which recommendations provide the best price-performance trade-off. The analysis and visualization of your usage patterns can help you decide when to move or resize those running instances and still meet your performance and capacity requirements. The right sizing recommendation preferences feature helps to customize the settings you want Compute Optimizer to consider when generating your EC2 and autoscaling group instance recommendations. This feature gives you the ability to adjust both the headroom and the threshold of your CPU utilization, configure a specific loopback period option, and set instance family preferences at the organization, account, or regional level. This provides you with greater transparency on how your recommendations are generated and the ability for you to configure EC2 right-sizing recommendations for higher savings and performance sensitivity. I'm going to stop this lesson here because it's gotten really long and I'm struggling with my mouth to say words correctly. But in our so this lesson covered tasks 4.1 and 4.2 of domain 4. In our next lesson, we're going to wrap up this new playlist episode series, and we're going to talk about task 4.3, which is to secure our AWS resources.